Hi guys. Sorry for the delay. In fact, this is Varun Chebbi from Bangalore. So basically, today I'm here to present my research work on CFD simulation on cloud platforms. So basically, my main research work was not on data analyst or AI or not other things. So it's purely on high performance computations where we run the simulations of fluids and study the behavior of the fluid flow basically. So that was my research field. So so hope you guys know about the things where the flow such as in aerospace field it might be in turbomachinery renewable energy wherever the fluid flow takes place apart from the solid. We use this technology called computational fluid dynamics. So the with the advancement of technology and the digitalization, so we as a mechanical engineers believe that the work has to be conducted in a very smooth manner. No doubt, the problems are very complex, and still more innovations have to be carried out in many of the fields. So don't mistake me because I'm held up with my laptop where I was unable to do so. So I'm just presenting in my phone. So here you can see the screen. So my main presentation contains what is computational fluid dynamics, its applications and how in which all field the open foam and the fluid dynamics is used. So I have also run a simulation on the power platforms where I have shown that the efficiency of the Power9 systems along with the GPUs. So in the presentation further, we'll just include that. And coming to, we have also created an ecosystem in the India where I and Mr. Ganeshan sir, who is the OpenPOWER leader for education and research, have worked on creating an ecosystem among the Indian education system. So I'll just go through it. And what are the future scope of work? What are the goals we have in order to reach and do some good things out there? So let me start with the introduction by saying that we have many software tools such as answers and all those things in order to um, run the simulation and make the mechanical problems very easily. In order to solve these problems, we require a lot of engineering knowledge along with the HPC clusters. So what these HPC clusters do is it's more of a cloud computing kind of thing where the ease of computing, the high performance computing takes place. I appreciate the power systems for this because it's not only in terms of AI and data driven, but in terms of high performance computations where the problems are really high, of high complex, we can able to solve it. So coming to the background of computational fluid dynamics, we know that there is a equation called Navier-Stokes equation where we run these where all the simulations of the fluid dynamics are based on this. So let me brief you about this Navier-Stokes equation. So in our school days, we would have studied about the inlet and the outlet velocity of the flow along with the time. So this Navier-Stokes also works in the similar way where the viscous fluid flows with respect to time and the difference of the fluid flow, and at that particular point the fluid characteristics are studied, and main problems can be physical problems can be determined. So coming to the conventional definition, so computational fluid dynamics is nothing but a branch of fluid dynamics where we study the fluid flow along with the help of boundary conditions and the super speed supercomputers for the better solutions and the accurate accurate results. So coming to the applications, we have seen many of the industries using this tool, where we the ease of maintaining the room temperature and the data servers. So we design this data cooling room so that in order to prevent the heat produced, and also the feasibility of the weather temperature in terms of, in the days where the COVID-19 situations were there, the flow of infections reduction was a major problem. So hence HVAC and the CFD played a major role in the maintaining the corporate offices and other things. And also we use CFD in automobile and aerospace field, where the design and drafting of the aerospace and automobile takes place. And I'm also currently working on the aerospace domain, where there is lots of research scope, because nowadays what has happened is the Indian government, in India we have the privatization in the aerospace industry, so there is lots of scope, not only in India as well as abroad. So the space researches are going on and there is a huge scope. And coming to electronic circuits and batteries, with the growth of the technology of electric vehicles, there is lots of thermal and flow problems, where the heat is produced. In order to reduce the heat and and monitor amount of heat, we use such technologies for the computation of the fluid flow. And coming to renewable energy, you know that the wind, solar, everything creates a radiation and also the fluid flow. So hence this concept of computational fluid dynamics is used. And also it is used by the astrophysics, where they study about the space and other parameters, and also naturally the turbo machineries and other things. So let me, as I wasted my time in solving the technical issue here. So I'll just jump few slides. So the major players are the ANSYS of power flow, and out of all this, OpenFOAM is one of the tool where it is used by any, as it is a open source tool, where we can run, where there is no limitation for anything. Either it may be a mesh generation, or any sort of boundaries it might be. There is no boundary for it, until and unless we have a supporting hardware such as IBM Power Systems and HPC cloud clusters like IBM Power9. So there is no boundary conditions. But whereas in ANSYS and other tools, there are limitations, and they are more of business oriented organization, what I would call is. So coming to what is the advantage of this cloud computing. So there is low initial cost and easy backup and elastic computing resources. So in the age where the economic constraint comes into the picture, even an individual, according to his requirement, can a mechanical engineer or an aerospace engineer can explore his fields, where he can learn his own simulations and make the things done. And the storing of data is no longer a big issue nowadays, because of the cloud and all those upcoming technologies. So coming to my the work which I have done, I would like to share. So basically, CFD simulation consists of three major parts. It's pre-processing, solver, solution, and the post-processing. Uh, it's in your AI, you would have heard about the neural networks, because in terms of mechanical engineers and all the CFD enthusiasts, this neural networks is a very new concept. And rather, we also have this we provide the input, such as the initial conditions, what type of the fluid is flowing through, and other parameters when we are inputting a fluid inside a solid workplace. So solver, what it does is it takes all your data, input data, and all the constants. So by default there are many equations, and the solutions are already present, where the computations takes place using this cloud computing concept. And some amazing things is done by this Power9 systems, so that we can get the results very easily and very fast mode. So in post-processing, what we get is we obtain a graphical output for the user interface, where the interpolation of results for this various parameters takes place. So its post-processing is all about the analysis of the result to the real-time mechanical results, where we calculate using the MATLAB and other tools such as Fortran and so on. So the main aim of my research work was we used we used a fuel fluid flow in the aerospace aircraft. Basically, actually it's a confidential project, so I just took a part of it and I'm just explaining you. So this is the OpenFOAM input pre-processing screen, where we input all these parameters, such as the fluid type, the fluid gradient, the inlet velocity, and the pressure of inlet, and other parameters such as the starting time, the end time, and at what time you just need to obtain the result, where you get the at what time the characteristic of fluid is doing. So, and these each and every point you get the data, and at each and every coordinate you get the data, and every second, every minute second, if you need, we get the data. So that is the beauty of this software called OpenFOAM. As anyone in this world can use it, as it is an open source tool. But the problem with this is we need to code the stuffs. As I have told you that we don't have any borders, boundary conditions, and other things, so it is easy to perform our computations. So this is the CAD design which we input in our post pre-processing, and we just go for the meshing. What basically meshing is, we just divide the as a computer aided design into billions of parts, where at what time we just need the result, the accurate result. So the hence we divide the model into billions of parts, where we integrate and get the result done. And this is the solver. We just this is the place where all the computations takes place. And this is the user interface called ParaView, where all the simulations and computations are visible to your eyes using the Power9 GPU processors. So this is the ParaView where the results are obtained. So this is the post-processing, where your graphs and other results come into picture, and you can tally with your real-time experimental data with the machine. So here is the post-processing screen of the OpenFOAM, where you can see the time, at what time, what is the behavior of the fluid flow. At you can see the screen that at the point of 41.8 second, these are the constraints of the fluid, and at what time, at what place, at what coordinate the fluid is located. So it's a beauty of the technology, my friends. Basically, anything, what I believe is, after starting my career, the problem statement has to be very clear. With the advancement of the technology and the computations, so any problem can be solved, but our problem statement has to be very clear. So these are the results at the time of 75th second, the coordinates, the fluid flow, the what is the temperature, and all those constants are visible here. Okay, so apart from our computation and research, we have me, myself, and Ganeshan Narayan Swami sir, who is the OpenPOWER leader for education and research, have created an ecosystem in India, so that people take the interest in these kind of technologies, where we still see people use old conventional machineries, lathe machines, and all other things. But why not? And the place where I come from, the Bangalore, it is called the Silicon Valley of India, and more people are into the IT jobs. But and they it's more of a ecosystem where the IT professionals are present. In that place, we encourage the mechanical engineers to take up such challenging and technologies and work on the same. So these are some of the pictures I would like to share. So what is the future now? So we have done all the research and all the things, but how it can so how it can so how it can benefit our society. So what our future plans are, to in fact encourage the startups in terms of education and research. And also our aim is to create an ecosystem where the artificial intelligence and machine learning takes place in terms of CFD, where there is huge amount of data, and the previous data we models can be treated, and other things can be done. So I would like to end my talk, as I think that I'm very late and due to technical issues. If there is any Q&A, question and answer, I would surely answer you guys. I'll be very happy to answer the same. Thank you so much. And sorry for the delay. There was a technical issue.